Now, Newton's first law is clearly against our daily experiences. Things that move don't move along a straight line and don't continue to move. And the reason is there's gravity. And there is another reason. Even if you remove gravity, then there is friction. There's air drag. And so things will always come to a halt. But we believe, though, that in the absence of any forces, indeed an object, if it had a certain velocity, would continue along a straight line forever and ever and ever. Can Newton's law be proven? The answer is no, because it's impossible to be sure that your reference frame is without any accelerations. Do we believe in this? Yes, we do. We believe in it since it is consistent within the uncertainty of the measurements with all experiments that have been done. Now we come to the second law, Newton's second law. I have a spring. Can the second law be proven? No. Do we believe in it? Yes. Why do we believe in it? Because all experiments and all measurements within the uncertainty of the measurements are in agreement with the second law. Now we come to Newton's third law. If one object exerts a force on another, the other exerts the same force in opposite direction on the one. I read it again. If one object exerts a force on another, the other exerts the same force in opposite direction on the one. And I normally on one, but in opposite signs. Is this a proof? No. Can the third law be proven? No. Do we believe in it? Yes. Why do we believe in it? Because all measurements, all experiment within the uncertainties are consistent with the third law.
Now I'm going to discuss how we would look for a new law. In general, we look for a new law by the following process. First, we guess it. Then we well, don't laugh, that's really true. Then we compute the consequences of the guess to see what, if this is right, if this law that we guessed is right, we see what it would imply, and then we compare those computation results to nature, or we say compare to experiment or experience. Compare it directly with observation to see if it works. If it disagrees with experiment, it's wrong. In that simple statement is the key to science. It doesn't make a difference how beautiful your guess is. It doesn't make a difference how smart you are who made the guess or what his name is. If it disagrees with experiment, it's wrong. That's all there is to it.